Hello, wow, look at all these oscillations here, so energetic. So do oscillations have energy? Yes, of course, we call it the energy of oscillation. So what will be the formula to describe the energy of SHM? To answer that question, let's start with an oscillation that has zero energy, which means an oscillation that has not started yet, yeah? So this mass is still resting at its equilibrium position, so it has no energy of oscillation. So how do you start the oscillation? You have to displace the mass from its equilibrium position, right? So the act of displacing the mass is when you impart energy into the oscillation. Get it? Now remember, an oscillation always have a restoring force. So when you try to pull it away from the equilibrium position, you got to apply an external force to overcome the restoring force. So the work done by the restoring force is the energy of the oscillation. Get it? So remember how we derived the formula for GPE? We just reasoned out that we require an external force, a constant external force of mg to overcome the gravitational pull to move an object by a height of h. And therefore the work done by this force is mgh. We use the same trick to derive the formula for elastic potential energy, right? So to stretch a spring, you need an external force that varies according to the extension. So the work done by the external force given by this triangular area turns out to be half ke squared. So we are going to use the same trick again to derive the formula for the energy of a SHM. So for a SHM, the external force you need to apply again is not a constant force. It's a force that's directly proportional to displacement, because the restoring force is directly proportional to displacement. If you remember, the maximum acceleration of a SHM is omega square x naught, then you understand why the maximum restoring force is m omega square x naught. So to displace something from its equilibrium position to an amplitude of x naught will require external force that looks like this, and therefore the work done by this external force is the area of this triangle, which is half base times height, which is half x naught times m omega square x naught, so equals to half m omega square x naught square. So this is the formula for the energy of a SHM. Easy peasy. Alright, that's all. Ta-ta. Wait, another thing. Now, so this is the formula for any SHM. But if you are talking about a spring mass system, then we know that the maximum restoring force is actually kx naught, where k is the spring constant, yeah? So in that case, the energy of the oscillation is just half kx naught squared. It looks very similar to the elastic potential energy formula, but be careful, For the EPE, the extension is measured from the unstretched length, yeah? But for a SHM, the amplitude is measured from the equilibrium position. So take note of that. Okay, that's all. Ta-ta!